This is 4.2, graph linear equations in two variables. Section B, graph a linear equation by plotting points from OpenStax elementary algebra. So we have learned how to plot points on a graph, and then you did learn how to put a line through it. And so this is going to be a lot of review for you, but I wanted to review this again because we did it quite a while ago. And then we're going to use this to go into some other concepts. So hopefully this is a nice review for you guys. And so let's go ahead and jump in. There are several methods that can be used to graph a linear equation, and I'm going to go ahead and list some of those. This is not an exhaustive list, but we have plotting points, which is also known as point plotting. We have intercepts, point slope, slope and y-intercept, slope-intercept equation. And so what we are going to be talking about today is plotting points, which, like I said, we've already done this, but I wanted to review it again and give you some more practice before we move on. We're also going to look at some types of equations to use plot pointing with that we haven't used yet, and some different ways to approach it. So, how to graph a linear equation by plotting points. First, you find 3 points whose coordinates are solutions to the equation. Now, just a quick note here, it only takes 2 points to define a line, right? If I have any 2 points, let me back up and get my pen, sorry. If I have any 2 points, right, if I connect those 2 points, I'm going to attempt to do this. If I connect those points, I have a line. Right? So it only requires 2 points to define a line. I'm going to tell you, and I'm going to require you to find 3 points when you are graphing an equation this way, because that is going to help you check to make sure you did it right. Okay, if you find 1 point and it is a correct point, but then you find another point and it is an incorrect point, you still get a line and you will think that you found the correct answer. However, if you find 3 points, let's say you find 1 point and then you find another point and then you find a third point, and they're not all in a line. I can't draw one straight line going through those points. I either have to draw here or here or here, but there's not one line that contains all of them. Then I know that at least one of my points is wrong. I did one of my calculations wrong. So by finding 3 points, it's going to help you check to make sure that you are finding the correct points for the line. So find 3 points whose coordinates are solutions to the equation. Remember, that's going to end up being an x and a y coordinate. Next, plot the points. If they do not line up, check for mistakes, which I already mentioned. And then draw a line through the 3 points. Now, this is important. You need to extend the line through the whole plane and put arrows on both ends. Okay, so if my points are here, I'm going to extend the arrow or the line all the way through until I'm at the edge of my coordinate plane and put arrows on both ends, because what that's going to do is that's going to indicate that that line goes on forever in both directions, because that's the definition of a line. So let's look at an example to see what this looks like. Example 4.11. Graph the equation y equals 2x plus 1 by plotting points. And so you've seen this table before. You've seen this form of a table where we have the equation on the top, we have a column for x, a column for y, and a column then for the coordinate pairs, the ordered pairs. And so we can pick any value of x to put in here. Okay, I would suggest starting with 0. 0 is an easy place to start, because when you multiply your coefficient times 0, it's going to turn into 0. Right, and then you get y equals 1. Okay, so I put 0 in for x and I got y equals 1. So my ordered pairs are 0, 1. Okay, then I'm going to pick another one. I'm going to go ahead and just pick 1. I'll put 1 in there. 1 is easy to multiply by. Y is equal to 2 times 1 plus 1. Oh, that's a plus. And that is equal to 2 plus 1, which is equal to 3. So I know that when x is 1, my y is equal to 3. So my ordered pairs are 1, 3. And then I'm going to put 2 in for x. Y is equal to 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5, so I'm going to put 5 here, and my ordered pair is 2, 5. Okay, so I have found my ordered pairs. I found my solutions, right? These are solutions to this equation. Now I'm going to plot them on my Cartesian plane or my coordinate plane. So let's go ahead and do this in order, 0, 1. So I'm going to, I know that I'm going to define each of these lines as 1. So this is 1, 2, 3, 4. Same thing on the y, 1, 2, 3, 4. Excuse me. So I need 0, 1. So on the x-axis, I'm going to go 0, left or right. I'm just going to stay on the y-axis. And then I need to go up 1 on the y-axis. So I'm going to put a point right there. Okay. And then my next one is 1, 3. So starting at the origin, I'm going to go 1, positive 1 on the x-axis. And oops, sorry, I shouldn't have put a dot there because we hadn't gone up 3. Should have just counted. We're going to go positive 1 on the x-axis and then up 3 on the y. 1, 2, 3. There we go. Okay. And then I have 2, 5. Starting at the origin, I'm going to go positive 2 on the x. 1, 2. And up 5 on the y. 1, 2, 3, 4, 5. And there I get my third point. Okay, so now I can see that if I draw a straight line through those, I'm going to hit all 3 of those. And of course, if I was doing this on paper, I would use a straight edge to get that nice and straight. I do not have a straight edge that I can use on my digitally on this computer, and so I'm going to just put in some extra points here to help me draw that straight line. Hopefully I put all my points in correctly here. Okay, and then I'm going to, as best as I can, draw. I'm going to sketch this line in here. Sorry, it's not pretty, but you get the idea. And then remember, so it has to go as far as it can through that coordinate plane till it runs into the edge, and then I need to put arrows on both ends because that line will continue forever in this direction and forever in this direction. So remember, this line means that any point on this line is a solution to this equation. Okay, so the x-coordinate 1.5 would be a solution with the y at 4, 1.5, 4. I know that because I can see it on here. Now, obviously, because I didn't draw it exactly, it's hard to tell that. But if I had drawn it nice and straight, you would be able to see that. Okay, so that is how you graph a linear equation by plotting points. Okay, so here's a try it. Go ahead and try this yourself. Pause your video, try it, and then play the video to make sure that you did it correctly. So I'm going to go ahead and plug in, for my x, I'm just going to do the same as I did last time. I'm going to put 0, 1, and 2 in here. I'm going to solve for my y. So y is equal to 2 times 0, that's a 0, not a 6, 0 minus 3, which is equal to 0 minus 3, which is negative 3. Okay, so when x is 0, y is negative 3. So my ordered pair is 0, negative 3. Okay, and now I'm going to plug in 1 for x. Y is equal to 2 times 1 minus 3. 2 times 1 is 2. Minus 3 is negative 1. So when when x is 1, y is negative 1. So I have 1, negative 1 here. And then y is equal to 2 times 2 minus 3. 2 times 2 is 4. Minus 3 is positive 1. So my ordered pair is 2, 1. Okay, now I'm going to plot this. 0, negative 3. 0, negative 3. 1, 2, 3. So it hits the y-axis right there. And then 1, negative 1. 1, negative 1. 2, 1. 1, 2, 1. And then ideally I would use a straight edge. Oops, see, I didn't do that very well freehanding it. Make sure you go all the way across as far as you can on your coordinate plane and then put arrows at the end. Hopefully yours looks a lot better than mine because you used a straight edge on an actual tabletop on a piece of paper. So check your answer. If you need to rewatch that to see why the answer is what it is, then please do that. Sometimes an equation will include a fraction as the coefficient of x. Remember, a coefficient is a number in front of a variable, and so sometimes you will have a fraction in front of your variable. When you're doing this, you can plug in any value for x, right? As you're choosing numbers to put in your table, you can choose any value of x. Any value will work. However, choosing values of x wisely can make graphing easier and more precise. You don't want to have to try to find where fractions are on the coordinate plane. You want to deal with integers. They're a lot easier to find and your graph will be more precise. Generally, if you choose values that are multiples of the denominator, you will be in a good position. So let's see what this looks like. Example 4.13. Graph the equation y equals 1/2 x plus 3. Y equals 1/2 x plus 3. So we want to be wise in what we choose to put in for x. We're not just going to do 0, 1, 2 like we did before, but we're going to think through what numbers would work best. I am going to use a 0 because I know if I make x 0, then this fraction disappears, and that makes it easy. Okay, so I'm going to go ahead and put a 0 there. So y is equal to 1/2 times 0 plus 3. 1/2 times 0 is 0, plus 3 is positive 3. So my first ordered pair is 0, 3. Okay, now if I put a 1 in for x, I'm going to end up with 1/2 plus 3, which is 3.5, which is fine, but not as precise when graphing. And then also, that would be a lot messier if, for example, I had 7/8 as my fraction, or if I had 5/7, right? So in order to, even though this is an easy one because it's 1/2, to show you how to do this, we are going to wisely choose our x. So I mentioned on the previous slide that if I choose a multiple of the denominator, it will help get rid of that fraction. And so my denominator is 2. The lowest multiple of 2 is 2. So I'm going to put in 2 for x. Okay, so let's see what we get. Y is equal to 1/2 times 2 plus 3. Okay, 1/2 times 2 is equal to 1 plus 3, which is equal to 4. Okay, so notice how by choosing wisely, by using 2, we got rid of the fraction. We ended up with an integer down here. So my second ordered pair is 2, 4. Okay, now I want another multiple of 2. So the next highest multiple of 2 is 4. So I'm going to put in a 4 for the x. Y is equal to 1/2 times 4 plus 3. 1/2 times 4 is 2 plus 3 is equal to 5. So I'm going to put my 5 in for my y. My last ordered pair is 4, 5. Okay, so let's go ahead and plot that. So we have 0, 3. 0, 1, 2, 3. The point right there. And then we have 2, 4. 1, 2, 1, 2, 3, 4. Put it in there. Make these a little bigger. And 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Here's our next point. Okay, and then of course, if I had a straight edge, that would be a little easier. I know that I'm going to have that my line should go through these points. So I'm going to add those just so it makes it a little easier for me to sketch this line without a straight edge. So it's going to go something like this. There we go, kind of like that. Don't forget your arrows, right? It is wrong if you don't put the arrows because that line, that equation does describe a line that goes on forever. So that's how you deal with equations for a line when you have a coefficient that is a fraction. Okay, I'm going to put up a try it problem for you here. You're going to graph the equation of y is equal to 1/3 x minus 1. So before I let you go and have you pause it, let's think about what values we want to put in for x. Right? If we put a 0 in there, then that fraction disappears, so that's a good one. Oops, forgot to turn it to my pen. Okay, so if we put a 0 in there, let's do that. And then we want multiples of our denominator. Our denominator is 3, so the lowest denominator, or the lowest multiple of 3 is 3 itself. Let's go ahead and put that in for x. And then the next multiple of 3 is 6. Okay, so go ahead and pause the video, continue solving this, and then come back to make sure you did it correctly. Okay, let's go ahead and plug these in. Y is equal to 1/3 times 0 minus 1. 1/3 times 0 is 0. Minus 1 is -1. So I'm going to put my -1 in here. My ordered pair is 0, -1. That's a 1, sorry, not a 7. Okay, now I'm going to put 3 in here. Y is equal to 1/3 times 3 minus 1. 1/3 times 3 is 1 minus 1. Oops, that's a 1. I don't know why my 1s keep looking like 7s. So 1 minus 1 is 0. Put my 0 here. That means my next ordered pair is 3, 0. And now I'm going to put 6 in there. Y equals 1/3 times 6 minus 1. 1/3 times 6 is equal to 2 minus 1, which is equal to 1. So 1 goes in here. My last ordered pair is 6, 1. So let's go ahead and plot this. 0, -1 is right here. 3, 0, 1, 2, 3, and 0, so that's right here. And 6, 1. 1, 2, 3, 4, 5, 6, 1. Okay, and then I'm going to add some other ones that I know are in here so that it's easier for me to sketch. But once again, you don't need to. You could just use your straight edge or your ruler in order to draw this line in here. But I'm freehanding it, so I'm going to do that. There you go, and that's what your line should look like. Hey, if your line doesn't look like this, go back, look at what you did, watch what I did again, and figure out where you made your mistake. Okay, sometimes equations will have the x and the y on the same side. So let's look at some that are like that. The first step you're going to do is you're going to solve the equation for y. Now remember, that doesn't mean you're necessarily going to find a number. And in fact, I'm going to tell you you're not going to find a number. You're going to end up with another equation. Okay, you're going to start with an equation with the x and the y on the same side. You're going to end up with an equation with y by itself and everything else on the other side. And then you graph it as normal. So let's look at what this looks like. Graph the equation 3x plus y is equal to -1. 3x plus y is equal to -1. So let's go ahead and pick values for, well, sorry, we're not there yet. First we need to solve for y. So we have 3x, I'm going to rewrite it down here, plus y is equal to -1. I want to get y by itself, which means I want to get rid of this 3x on this side, and I want to put it on this side. So what I need to do is subtract 3x from both sides, and I get y is equal to, now instead of just subtracting 3x from -1, I'm going to put the minus 3x in front of the 1. The -1. That way it's in the same form that we've been working with, where we have the y equals and then the x term and then the constant term. This is going to be really important later because you're going to want it in that form. So y equals -3x minus 1. So I have solved that equation for y. Okay, that's what I mean when I say solve it for y. I still have variables, I don't have numbers, that's fine. I have solved this for y. Okay, so now I want to be smart about what numbers I put in here. Let's go ahead and start with a 0, right? Because a 0 is going to make some of this disappear. Y is equal to -3 times 0 minus 1. 0 minus 1 is -1. 0, -1. And I don't have to fill in this whole chart before I start plotting. I can go 0, -1, and put that in there now. Okay, let's go ahead and put a 1 in there. Oh, a 1 in for that, because there's no fraction that I need to worry about, so I can just pick a 1. -3 times +1 minus 1. Okay, -3 times 1 is -3 minus 1 is equal to -4. -4. So I get 1, -4, 1, -4, 1, 2, 3, 4. right there. Okay. Now we've been putting zeros and positive numbers in for x. What happens if we put a negative number? Let's see what happens there. Y is equal to -3 times -1 minus 1. Okay, -3 times -1, right? A negative times a negative is a positive. So that equals +3 minus 1. So 3 minus 1 is 2. Oops, I put a -1 here and a 2. So my ordered pair is -1, 2. So -1 and +2, and there's my next point. Okay, so now I have my three points, and they are in a straight line. Let's see, I'm going to go ahead and put in other points that I know are in this line just to make it easier for me to sketch it. But like I said, you don't need to put these in. Oh, come on. You can just use your straight edge. There we go. You can use your straight edge in order to get your line to look nice and pretty. And your arrows at either end to indicate that it goes on forever. Okay, so that's how you deal with an equation when you start with the x and the y on the same side. I'm going to put up a try it problem for you. Graph the equation 2x plus y is equal to 2. So go ahead and solve for y, and then find your ordered pairs and graph it, and then come back and make sure you did it correctly. So to solve for y, 2x plus y is equal to 2. I'm going to move the 2x to the other side. Y is equal to -2x plus 2, right? I want that x term first before the constant. Okay, I'm going to go ahead and put a 0 in here. Y is equal to -2 times 0 plus 2. -2 times 0 is 0 plus 2. So my y is 2. My ordered pair is 0, 2, 0, 2. There we go. Okay, let's put a 1 in there. There's no reason why we can't put a 1. Y is equal to -2 times +1 plus 2. -2 plus 2 is 0. So my y is 0. X was 1. Y is 0. 1, 0. 1, 0. Put my point right there. There we go. And then let's go ahead and put a 2 in there. Y equals -2 times 2 plus 2. -2 times +2 is -4. I'm going to come down here instead of going up there. -4 plus 2 is equal to -2. So then I had +2 is my x, -2 is my y, 2, -2, and then I will plot that over here. 1, 2, -1, -2, and here's my next point. Okay, and then I'm going to add other points that I know are in this line so that I can sketch it a little better for you. Go ahead and, ooh, that's not a good line, but you get the idea. Arrows at both ends to indicate that it goes forever. Okay, so check yours against mine and make sure that it looks better than mine. Yours should look better than mine, but if you don't understand, rewatch how I did it, see how you did it, and find out where you went wrong. There is another way to graph linear equations. The first thing you would do is let x equal 0 and solve for y, and that's what we've been doing. We've been putting 0 in for x as the first step on most of these. But then instead of choosing different values for x, let y equal 0 and solve for x. This is going to help you identify where your line crosses both of the axes. And then you choose another value for x to check it. Based on the definition of a line, you don't have to have another point in order to create that line, but it would help you to check it. Let's see what this looks like in practice. So we're going to graph the equation 2x minus 3y is equal to 6. 2x minus 3y is equal to 6. So let's go ahead and do what follow those steps. It said make x equal to 0 and solve for y. Okay, so we don't even need to solve for y to do this, and actually I would recommend not solving for y to do this because y has a coefficient on it that is not a factor of both of these numbers. If we were to solve for y, we'd end up with a fraction. Let me just show you that real quick. 2x, no, not plus, minus 2x minus 3y is equal to 6. So if I move the 2x to the other side, and then I would have to divide by -3, and then I would get 2/3 x minus 2. So then I have a fraction and I'm having to deal with that. So I'm just going to leave it the way it is right now and do this. Okay, so I'm going to put a 0 in for x. I get 2 times 0 minus 3y equals 6. 2 times 0 is 0, so that disappears. That whole term disappears, and I get -3y is equal to 6. Therefore, y is equal to -2. Okay, so when x equals 0, y equals -2. My ordered pair is 0, -2. Okay, now I'm going to let y equal 0. Okay, so this is the first time where we've picked a y and plugged that in and then solved for x. So I get 2x minus 3 times 0 is equal to 6. -3 times 0 is 0. That whole term disappears, so I get 2x is equal to 6. Divide both sides by 2. X is equal to 3. So I said y is 0. That means my x is 3, and my ordered pair is 3, 0. Okay, and then I can pick any value I want for either of these, plug it in to double check. So since I already did work out my equation and set it equal to y, let's go ahead and use this, and let's pick a multiple of the denominator, which is 3. So we already used x equals 3, so let's use x equals 6. Y is equal to 2/3 times 6 minus 2, and then 2/3 times 6. The 3 is going to cancel out, and that's going to leave 2 here. So it's 2 times 2, which is 4 minus 2, which is equal to 2. Okay, so when x is 6, y is 2. So my ordered pair is 6, 2. Oops. Okay, so we can plot those. 0, -2, 3, 1, 2, 3, 0. Okay, so there, those are the ones that we used. X is 0 and y is 0. See, notice that's where it crosses the axes. And I could sketch my line from those, but I'm going to use the 6, 2 to double check. 1, 2, 3, 4, 5, 6, 1, 2. And I do see, in fact, that if I sketch a line straight through those, it does hit that one as well. And we're going to just eyeball the rest of that one and hope it's somewhere close. Okay, so that's how you can use, those are called the intercepts. When you set x equal to 0, that gives you the y-intercept. When you set y equal to 0, that gives you the x-intercept. So you can use the intercepts to graph by plotting the points where it intercepts those, where the line crosses those axes. So let me put a try it up there for you, and you can go ahead and try this. Graph the equation 4x plus 2y equals 8. So first you're going to set x equal to 0, solve for y. So we can go ahead and write that in here. You're going to set x equals 0 and solve for y. Then you're going to set y equal to 0 and solve for x, and then you're going to pick a third one just to check. Pause the video and come back and check. So let's go ahead and plug 0 in for x. Plus 2y is equal to 8. This disappears. 2y is equal to 8. Y is equal to 4. So when x equals 0, y equals 4. And I get 0, 4. Now I'm going to set y equal to 0. 4x plus 2 times 0 is equal to 8. This term disappears, and I'm left with 4x is equal to 8. Divide both sides by 4. X is equal to 2. So my ordered pair is 2, 0. And then I want to check in order to see, to make sure I got the correct answer. So let's go ahead and just say y is equal to 2. And we don't have to put it into the form where we solve for y. We can actually just plug it in. So 4x plus 2, and I'm going to say that y is 2, times 2 is equal to 8. So that gives us 4x plus 4 is equal to 8. Move the 4 to the other side by subtracting. 4x is equal to 4. Divide both sides by 4, and I get x is equal to 1. So then I have 1, 2 there. Okay, so let's go ahead and graph these. So at x equals 0, y equals 4. 1, 2, 3, 4. And at x equals 2, y equals 0. So that's going to be here. And then, to double check, I have the ordered pair 1, 2. 1, 2. And it looks like I did it correctly because all three of those are in line. Let's see if I can get my point to go there. Oh, come on. It wants it just right. There we go. Okay, and then I'm going to eyeball this one again. Of course, you'll use a straight edge to get this. Wow, that was a really bad line. Sorry, guys. But you get the idea. So check yours. Make sure it looks like that. If you got something different, go back and check each step of your calculations, and then check mine and see where you went wrong. Of course, you could have always picked different values to put in some of these, but your line should come out the same. Check your Google Classroom for your assignment. If you have any questions, please reach out to me. I really want to help you.